Okay, so we are going to begin our notes now. And where you need to be in your notes is on page 7. And we're going to finish up our rules. So we started the rules the other day in class with the fact that nothing can be perfect on the radical. And that's what you guys just did on that one side of the pink page. You took something like this, and you made your perfect and you made your not perfect. So I'm not going to go over that with you because we just did a ton of problems. So instead what I want to address are the other two rules. So the first rule says that I can't have a fraction under the radical, but I do want to try to simplify the radical first. So for instance, if I just have the cubed root of, and let's put 4 and 20 and x to the 5th, I can't have a fraction under or inside that radical. So the first thing I'm going to do is just quickly simplify. I call this the less is more. So I'm going to take the 4 and the 20 and divide a 4 out of both of them, and that leaves me a 5 in the bottom. And then the x's, I don't need an x on the top and 5 on the bottom. I can just have x to the 4th. I do need something in the numerator, so I'll put a 1 here. But if the x's had been in the top, I wouldn't have needed that one. So I did do this part. I did do the simplifying first, but now I'm going to deal with this rule that says no fractions under the radical. And that means I'm just going to break this up into two cubed roots, one on top and one on bottom. And now when I look at this rule, I don't have a fraction under the radical. The other rule that is there is you can't have radicals in the denominator. So unfortunately, fixing the first rule caused a problem with the second rule. I have a radical in the denominator and I can't have that. So we're going to go about this process of fixing the denominator. This is known as rationalizing the denominator. When we rationalize the denominator, we're making it perfect. So we have already talked about, that the square root of x squared is x, and that the square root of 7 squared is 7. And then when we did these, we got x and y to the third. So what we're going to do is try to make something like this not perfect become perfect. So the best way to do this is just to start, and we're going to turn our page and we're going to go here. So we've already done this first column. I'm not going to redo this problem with you, but we're going to take a look at the fourth problem. So not the fourth problem, but the one with the fourth root. So the first thing we've already written here, but I want you to simplify. That means you're going to multiply, which we already did in that first column, or you're going to divide. And what I mean by dividing is just make it simpler. Less is more. So when I look at this fraction, I don't need 4 and 32. I'm going to divide, and I can actually divide a 4 out of both of them and end up with an 8 in the bottom. And then the x's, I don't need x's on top and bottom. I can end up with an x squared on the top, and the y's, I can end up with y squared on the bottom. So that's the simplifying part. Now what I'm going to do is real quick, I'm going to put these two steps all into one, is address the next rule that you cannot have a fraction, no fractions under the radical. And right now I do. This whole fraction is under the fourth root. So this is the next one that I call just break it up. So I'm going to break up the numerator and the denominator so they have their own fourth root. So what we want to do is to get this problem to look a little bit more like the problems that you did on the other page, like this. So what I'm going to do next is I'm going to use a factor tree on any numbers that I can make a factor tree out of. So in this problem, I can make a factor tree out of 8. So just over here, 8 can just become 4 and 2. And when I'm done, I've got all these 2's. So what I'm going to do right now is just rewrite this problem so that instead of 8, I'm going to write it as 2 cubed. So we haven't really done anything that's been too new here. We're just making the problem easier. We've broken it up, and now we've made a factor tree. So this is the part that can get a little daunting. And this is fixing the second rule that says you cannot have a radical in the denominator, and right now we do. So this process is called rationalizing. So we will rationalize the denominator. So I'm just going to rewrite the problem here. I wouldn't normally rewrite it, but this is just to show you that step. And if I rationalize the denominator, if I make it perfect, I'm going to build it up that it's so that it's perfect. Then if the denominator is perfect, everything can come out of the denominator. And then I don't have to deal with this rule anymore that says you can't have a radical in the denominator, because that radical is going to be gone. So what I'm going to do is I'm going to multiply it to fix it. And if I have a fourth root in the original denominator, I'm going to have a fourth root in this new fraction, because fourth roots can only multiply fourth roots. So what I want to start with is the 2. I don't have enough 2's right now. They're not perfect. But if I gave it one more, I would now have 4 2's, and 4 2's is perfect. And then I'm going to look at the y's the same way. Right now I have 6, and that's not perfect. But if I put 2 more there, then I'd have 8 y's, and those are perfect. So if you notice, I got this whole numerator that doesn't have anything there. And we're going to go back to the saying from last chapter, whatever you do to the bottom, you do to the top. So I'm just going to recopy it here. And what I want you to see is I'm taking this original fraction times 1. This fraction, anything over itself, is worth 1. So I'm not going to change the value of the original fraction here. I'm just going to change what it looks like. So that's the first step. I'm working on making it perfect. Now the second step is I'm going to simplify, which just means I'm going to multiply the numerators, which combine stuff, and multiply the denominators and combine stuff. So I'm going to do that right over here. To pause the video, so let me just pick back up. So what I'm going to do is start with my denominators. And the idea, what I'd like to do here is, instead of having 2 fourth roots, I'm going to combine them, so it's just 1 fourth root. And I'm going to combine the 2's, 2 cubed and 2, I can just make that 2 to the 4th. And then the y's, y6 and y2, I can combine those and make it y to the 8th. Now I'm going to put these two together. Instead of having 2 fourth roots, I just want 1 fourth root. But I don't have anything I can combine like I did in the denominator. So I'm just going to bring everything that's in the fourth roots and just put them under 1. So x squared, 2 to the first, and y to the second. So at this point, my original video got lost, so I'm remaking this part. So I'm going to finish this problem. And when you run into the next video, you're going to hear a little overlap. So just ignore it until you get to this part of us solving some examples on the next page of your notes. So what I'm going to do now is finally deal with my rule number 3 that says nothing may be perfect under the radical. So I'm going to take this problem. I'm going to rewrite it. I wouldn't normally rewrite it. And anything that's perfect is going to come out, and anything that's not perfect is going to stay in. So when I do this, I always like to start with the denominator because I know everything should be perfect in there. So let's start with this 2. 2 to the 4th is perfect. It comes out as a 2. Y to the 8th is perfect. It comes out as y squared. When I go to the numerator, those x's, there's not enough. So that x squared is still stuck in there. The 2, there's not enough, so the 2 is still stuck in there. And then the y squared is not enough, it's still stuck in there. And this is a great way to write the answer. They would probably write it though so that the 2 is first, and then you go x and y for the alphabet, and then your denominator. So that's what I'm going to put. So you're about to roll into the next video, just ignore it, the first part of it I should say, and then you will start doing these examples down here.